Let's take a look at 10.1 and we'll try some sample problems from the exercises in the textbook. I'm beginning with exercise number 10, which deals with the product table for the two dice. So I have the red die and the green die, and then the red die is listed first and the green die is listed second. So a 1 and a 1, a 1 and a 2, and so forth. So in number 10, it says determine the number for which the sum for both dice is the following. So in number 10, we're looking for a sum of 3. And let me get my yellow. So I want a sum of 3, and we can see 2 and a 1 and a 1 and a 2 are the only possibilities to give us a sum of 3. So our answer will be 2 possibilities. There are 2 ways to get a sum of a 3. Okay, and if we go down to number 14, we're now looking for a sum of 7. We're using the same table. I'm just going to switch colors here. So a sum of 7, a 6 and a 1, a 5 and a 2, a 4 and a 3, a 3 and a 4, a 2 and a 5, and a 6, a 1 and a 6. So we have, let me highlight that so we know which one goes with which problem. And so we have 1, 2, 3, 4, 5, 6 different ways. So to get a sum of 7, let's put the word ways on there. All right, and number 18, we're asked to find a sum of 11. Again, I'm going to switch colors, and I want a sum of 11. And let's see, a 6 and a 5, and a 5 and a 6. So we end up with only 2 ways. So we're using the table and just simply counting the number of ways on the table. So originally I had to construct the table, or you could look at the one that is done in the book. Excuse me. Okay, now we go to some geometric drawings for the next few problems. And in 32, we have a star. And what they want to know is the number of triangles of any size that can be found in this particular drawing. So this is going to be a little bit tougher to see. I'm going to start with the, very often I'll make notations for myself, and I'm going to begin by counting the small triangles we see. And we can see that there are 5 of those. Okay, then there are some large triangles. And this is where it gets tricky. So I'm going to try outlining these as I find them with different colors. If I can get this pen to cooperate. Okay. Okay, so I have one triangle there. I have a second triangle there. I have a third. Oops, I didn't switch colors like I thought I did. A third triangle here. Okay. And a okay, so we've done this one. Let me go back to my black. We've done this one, this one, and this one. And here's where it gets a little bit tricky because of the fact that we've drawn on top of this so many times. We're going to pick up actually a triangle for each one of these points here. So we have one there, we have one there, we have one there, and we have one there, and finally one there. So actually we end up with 5. So actually drawing on top didn't really help me a whole lot. So let's see if I can draw those for you, not on the star, but okay. So we've got the one that points down. We have the one that points to the left, and I'm counting that as the point. We have one that points this way, okay, which is this one. We have one that points this way, which is this one. And then we have one that points a little bit more down. So we end up with 1, 2, 3, 4, whoops, I wrote 4, 5. So it is a little bit more difficult to see them. So what I'm doing is I'm talking about this as the point. So we have 1, 2, 3, 4, 5. So total is 10. And I find the triangle ones are a little bit more challenging actually than the ones with squares. Okay, 36 we have squares. We have a 4 by 4, it looks like. One, 2, 3, 4. 1, 2, 3, 4. Okay, now again I'm going to do small. I'm going to start with what I call the 1 by 1s. 1, 2, 3, 4, 5, 6, 7, 8. We're counting the squares this time. 13, 14, 15, 16. So the very small ones we have the 1 by 1s, there were 16. Okay, when I go to the 2 by 2s, this is an example. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, when we go to the 3 by 3s, let me use a highlighter this time. Oh, the blue's okay. I'll do, there's 1, there's 2, there's 3, and there's 4. So for 3 by 3, we have 4, and of course for the 4 by 4, we have the one large square. So let's hope we end up with the right number. Okay, so we have 10 plus 20 would be 30 in all, and that's correct. Okay, so now if you felt like you were having difficulty with the two-dimensional, we kind of take it a step further to three-dimensional. I think I'm going to move to a new page. Actually, I'm not going to reproduce the drawing for this one, so we'll just go ahead and see if we can count them. There's 4 layers, 1, 2, 3, 4 layers on this particular three-dimensional figure, and the top layer has 1 box. I'm just counting total figures right now. The second one is a 2 by 2, so that's going to be 4 on the second layer. On the third layer we have a 3 by 3, so that's 9. So I'm counting all of them. The next layer is a 4 by 4, so we have 16. So if I add these up, I believe it's the same numbers I had over here. It's 30. Now directions tell us in this case that we're to determine the number of cubes in each stack that are not visible. So now I'm going to count on the first layer how many are visible. I'm going to count how many are visible and then subtract that from 30 to get the number that are not. So I see 1 on the first layer. I see 1, 2, 3 of the cubes on the second layer. On the third layer, I see 1, 2, 3, 4, 5. On the next layer, the bottom layer, I see 1, 2, 3, 4, 5, 6, 7. So it looks like we have 16. So I'm going to take 30 minus 16. That means 14 are not visible. And I found this particular technique works the best for me. You might find another technique that'll work better for you. So I count the total blocks based on the layers, just looking at the layers, and all of these were squares, so we had a single cube on top. We had 4 cubes on the next layer. We had 9 on the next one and 16 on the bottom. So that's the total in the entire figure. Then I count the ones that are visible and subtract that from the total to come up with the ones that are not visible. Okay, so that's to give you a little bit of practice with the figures as well as with the product table.